Welcome to this video where we're going to learn about strings in Python. Now, you can continue to use JES for the strings part, but eventually we're going to start using straight Python instead of using the Jython and JES. So you will need to install Python on your computer. So for a Windows machine, you'll just go to this website. It has a good tutorial on how to install it, and I'll put the URL in the notes. Just read through this, and we're fine with just Python right here, a Python version 2. If you want to do Python version 3, you can. There are a few differences, but I will be doing the videos in Python version 2. And then I'll show you what you would change if you want to do it in Python version 3. So all you have to do is scroll down here. They have links to be able to download Python. I just want, for Windows users, I want to make sure you do not skip this step right here. If you do that, your computer cannot find Python. It will be installed, but it won't find it, so you can't run your programs. So on a Mac, it's probably much easier. You just need to download the installer from the same website and install that. So you can have a link to the installer. I believe this link has versions for both Windows and a Mac. And again, make sure you do version 2 if you want to follow along exactly with the videos right here. So here's the Mac installer right here, and then the Windows installer right here. Now once you get that installed, another thing you might want to install is a text editor. And there's lots of text editors to install, and they're not complicated. You just download the file and install it. So this is a Visual Studio Code. This will work on both a Windows machine and a Mac. You can also download Atom Editor, and if you're on a Windows machine, you can also use Notepad++, which is installed on the lab machines. So I'll include links to all the different ones. You only need one of them. You don't need to install all of them. So I'm just using Visual Studio Code here because it'll allow me to show two things at the same time pretty easily, but you can really use any one you want. Now the editor that might be easiest to use for this might be the Atom editor. It's more straightforward, or so that's the one I would recommend, or Notepad++ if you're on Windows. There's no Notepad++ for a Mac. So the Atom editor might be the most straightforward, but if you did choose Visual Studio Code, you might go up here and try to create a new file and not see it at first. You just need to click on this little file viewer right here, and then you can click it and hide it, and then the new file should show up. I put a terminal over here on the side. That's not required. This is just nice and easy to record and show you everything. So after you've installed Python, you want to test it to see if it works. So with that, you'll want to open up a terminal window, and to find that, if you're on a Mac, just go to your applications over here on the side, and you'll see down here that there's a utilities folder, and right there is a terminal. You can also hold down the command key and then press space, and then you can start typing the word terminal, and it will come up, and that should launch the terminal right there. If you're on a Windows machine, you usually have a start menu down here with a search bar, or if you click the start menu, a search bar shows up. So all you have to do is start typing command CMD. That's C as in cat, M as in Mary, D as in dog. You'll see a command prompt open up. So on Windows it's called command prompt, and on a Mac it's called a terminal. So once it opens up, you'll get something that looks like this. It might look a little bit different. I've done some little customizations to this. Of course, on a Windows machine, a command prompt is going to look different as well, but the commands that you type in will be mostly the same. So CD just means to change directories, and hopefully you will start in your home folder If you're on the lab machine, you might click the command prompt and see that you're on the desktop folder. And here you could go cd space desktop right there, and now we're in the desktop. So this is change directories right here. So if you want to save your files on the desktop, which is what I'll do, I'll just save my files on the desktop. You just need to cd to the desktop. If you want to go back up a directory, it's just cd dot dot, and that goes up a directory that way, both on Windows and on a Mac. Now if you're on Windows, you can do dir, which stands for directory, and it lists out all of the files in the current folder. And if you're on a Mac, that command is ls. So if you're on a Mac, ls. If you're on a Windows, do dir. And this just shows you all of the files that in your current folder right here. So again, I'm going to go to the desktop. And I'm going to make sure that I save my Python file on the desktop as well. So to test out Python, if you installed it all right, just type Python. And if you notice, we have Python at 2.7. Don't worry about this not being recommended. But anyway, we can just type print hello. And we see we get hello right here. And then if we want to get out, we can exit. Now make sure you do exit, because you can't change directories and stuff once you've launched Python. So I've seen in the past some people forget to exit, and they're trying to, this is like the black part of JES, the bottom part of JES. So if you want to get back to the command prompt or the terminal, you just need to exit Python. So if that works for you, you got Python installed and you're ready to go. So hopefully you also installed your text editor, and you should be ready to go. Just create a new file and save it on your desktop. So I'm going to call this save. I'm going to call this strings.python.py. So now it's basically like we divided up JES into two different programs. Your text editor is the top part, or the white part, and that terminal or command prompt, if you're on Windows, is the black part underneath. You just have to type Python to get it started. Now, one of the main reasons we're moving out of JES is because in order to make your programs work, you had to type some Python code in the black part, or the command area of JES. That's not very user-friendly. If you wanted your friend to go use your program, you probably would just say, here, download this and run it. You probably wouldn't say, well, download my program, open it up in this file, and then type in this command to get it going. So this is on a path to be able to release programs that people that don't know how to program can run. So that's our first step towards that. JES was really nice to start learning it. But I've written a pretty simple program right here. It's just a program that prints hello class. And again, I didn't show it, but I did save it on the desktop instead of my home folder. So over in my terminal, now this, unless you figured out how to do this in Visual Studio Code, you probably just want to switch to your command prompt or terminal. You might make sure that you are in the same folder that you saved your file. And now you can run your program by going Python and then the name of your program. Make sure you get the spelling the same and the capitalization. So this is lowercase s, lowercase s. So when you do that, you see that we have printed out hello class for us. Now, this still is a little bit of typing for novice computer users, or most users that don't type stuff in the terminal. But there's a way that you can get this to turn into a launcher where you can double click on something and it will launch your program and run it. Now, I'm going to go ahead and turn this into a function called, define a function that says say hello. Right here. And don't forget to indent the body of the function, or this block right here. And so now we have a function that says, that does this. So we'll save that. And now we'll run our program again. By the way, you can press the up arrow to go to your previous command, so that's a pretty fast thing. And now you notice when I ran it, I don't get any hello class right here. And why is that? Well, this is our entire program right here, but remember when we define a function, we just write a recipe down on a card and we put it in our recipe box. We never told the computer to run the function. So down here, we'll call the function telling the computer to do our function right here. Now, that'll fix it. So now it does say hello again. And the way this works is the Python just does exactly what you tell it, step by step. So step 1, write a new function, put it in our recipe box or our function box. Step 2, call that function. And we can do step 3, print I just called a function. And so you see that this works right here. The only tricky part is when you define a function, that doesn't happen right away. That's just writing the function down on a recipe card or a function card and storing it in our little recipe box to be used later. So whenever we do something in a function, that's just putting a function in our recipe box. It doesn't make the function happen until we call it later on. So now we're going to talk about strings, and to do this I just want to type out some commands and see what happens. And the best way to do that is to go into Python. Alright, so what is a string? A string, hopefully you've used it before earlier in class, is anything that has double quote marks around it. So that's a string right there. Underneath, a string is really just an array of characters. So we got 1, 2, 3, 4, 5 different characters in our string. So we can, of course, assign names to strings, and we can use this length function to figure out how many characters are on the string, or the length of the array that makes up the string. Now we've used arrays when our getPixels returns an array and we've looped through them. So everything that we've done with arrays applies to strings as well. For example, if you remember these square brackets, say we'll get a spot in our array out. So we got the 0th character, the first, second, third, fourth. So remember we always start counting with 0, so we can just ask this string for the 0th character, and we get H, the first one, the second one, the third one, and the fourth one. Now something else we can do is we can go backwards. So if we do a negative character, -1, we get the very last character right here. So it's -1, -2, -3, -4, -5. So we'll just try all those. -2, -3 will get us the other L. -4 will get us the E, and -5 will get us the H. So you can go from 0 to 4 or -1 to -5, going back the other way. Another thing that we can do is we can kind of slice this string. Let's just say that I want to get the ELL out. So the E is in position 1, so 0, 1, E is in position 1, and then L, and it's a kind of a length of 3. So let's do that. And to do that, we use these square brackets again, but now we can put 2 numbers in. The first number is where we want to start, so we want to start on the E, which is in position 1, 0, 1. So we'll put 1 right there. And the second position, the second number is where we want to end, so that's L, L, so there's 1, 2, 3, but the ending point doesn't include the last one, so we want to actually end at 4. So it's starting here, ending here at the O, but not including the O. So we'll put 4 right there, and we'll get that part. And that's called slicing a string, so we can kind of take a little slice out in the middle of the string. A couple of things we can do with this is we can leave off the first number, and it starts at the beginning. And if we leave off the last number, it goes to the end. So that's some fun things that we can do with strings. And now let's get out of this. To get out of it, we want to exit. Now you want to make sure you exit out of Python so that you can run your programs before. I haven't changed it all, but if you try to do this, when you see these 3 greater than signs, this is not valid Python. This is valid for command prompts and terminals. So if you try to type that up here, you'll get an error. So make sure you just exit out of Python to be able to go back and run your programs. So I'm going to quickly write up another function right here, and it's going to be loop through my string. It's going to take in one input, we'll call it a string right here. And now we can go for each letter in my string. We'll just print our letter. So let's go ahead and see what happens if we do that. And if you notice, well, it's not doing any of this at all because we put that in a function. So hopefully remember from our previous discussion that this just created a function called loopstr, and it stored it in our recipe box, but we never run it. So what we have to do is go down here and actually call our function. And this makes sense because now our function takes input. It just can't run without having an input into it. So now we can just put something in here. Hello class. And we try running that, and you see that we print out each letter 1 at a time. All right, now that we've counted the letters, or printed out the letters in our string, let's do another function that will count the letters. And eventually it's going to count all of the vowels, or only the vowels in my input string right here. So what we'll do is we'll have our count right here, and we'll set it equal to 0 before we start. And then we'll say for each letter in my string, make count, or add 1 to count. And then when we're done with our loop, we can print out the count. So notice I moved back here, so this is the inside of the for loop. That's what gets repeated, and when the for loop's done, that's what's happened. So let's try this down here. We'll count the vowels. But right now it's going to just count all of the letters, and we'll just come up with a word hello, or a sentence, hello class, happy watching. Okay, and we'll save that and we'll see what Python does. By the way, I'm going to put a hashtag in front of that, this commenting out code. I don't want this hello class to get printed out every time I run it, because now I'm working on this function right here. So let's try that after we save it, of course. So as you see, hello class got printed out, but we did get that 27 there. So there are 27 letters in this, and that includes the spaces and this exclamation mark right there. So now instead of counting all the letters, let's just count the number of vowels right here. And I'm just changing the variable name. And now we'll just do a check. Is this letter that we're looking at a vowel? And the way we do that is if the letter is in, and we can go A, E, I, O, U. Okay, and so this should count all the vowels right there, and then we'll just go vowels plus 1. So we'll add 1 to vowels, and then that should count out all our vowels. So let's check. We got 1, 2, 3, 4, 5, 6 vowels that I counted. Let's see if I counted right. And let's run our program now, and sure enough, we get our 6 vowels. What happens if we have one of our vowels is a capital letter, like the A in class? Right here, notice it doesn't count it. So what can we do about that? Well, we could add capital letters to this. A-E-I-O-U. We could add capital letters to this right here. Another thing that we can do is we can make the letter lowercase with that thing right there and only have lowercase letters. So we'll talk more about this, but here's a way to count vowels in our program, or count certain letters. So one of your homework assignments, you're going to read in a string of M's and F's. M stands for male, F for female. You're going to count how many males and females are in, or what percentage of the string are M's and what percent are F's. So what is this lower thing right here that I added in? It takes a string or a character and it turns it into a lowercase letter. There's actually lots of little helper functions that help us change or it helps us do things to strings that could be helpful, so we'll work on those. So we're back in Python, so let's look at this. If we have a word here that has some capital letters and lowercase letters in it, and we want to make it all lowercase, we can just do lower. So that gives us a word with all the things lowercase, or we can have it be all uppercase. And there is one other one called title that capitalizes the first letter in each word and makes sure all the other words are lowercase like that. Now there are some other functions that help us work with characters and strings. One is called ORD. And if I pass in a letter, this gives me the ASCII code for that letter. So if you remember at the very beginning of class, we talked about binary and converting things to binary. Then we talked about ASCII and how there's a code that basically a lookup table. If we want the letter A in our computer, we use the number 65. So we can see that a capital A is 65, a lowercase a is 97, and let's try a capital Y, see what number that is. So if we want to figure out what the ASCII code is for a letter, we just use ORD. And there is a char function that does the opposite. It tells you if we have an ASCII code of 89, it tells you what letter it is. So you'll be using this ORD in one of your homework assignments as well. Now I've added a new function here. Eventually what I wanted to do is reverse the letters of a word. So if we have this word hello, what it should print out will be hello backwards, so O-L-L-E-H. So that's what I want this reverse word to do, but right now it's not going to do that. It's just a simple thing that can get us started. We're going to loop through each letter and we're going to concatenate that letter onto this variable here called the pile. Now the pile is just an empty string. And you might, I think I've talked about concatenation, and that's where we take two strings and we just combine them together to make one string. So we take the pile, which is an empty word, and we combine it with the letter, which is one letter, and that just puts the letter there. But then when we loop through to the next letter, the pile already has the first letter and the next letter gets added to it. So what I'm going to do is I'm going to print out my pile each time we add a letter so we can see how this works. And of course, if I want this and this isn't happening, the reason why it's not happening is I am not calling the function. So let's go down here below count vowels and we'll call reverse word right there. And we'll just put in a word like race. Well, we'll do hello class. How about that? So we could see our pile starts out with just an H, and then it has the HE, and then as we go through each letter in our word, we add one more letter onto this, so we build it up to hello class. Okay, but what will happen if we concatenate if we put the letter first? So in the first case, we're still going to get the H at the beginning, right? But then the next time, we're going to take the E. Instead of putting the E on the left side of the word, the E will go, or the E on the right side of the word, the E will go on the left side. So let's see how this changes things. Okay. And now we could see that our word actually goes backwards, and you could see that as we go through each letter, it's putting it over here. So our word at the end will be backwards. Okay. Your mirror strings homework, which is coming up, will have a function that does something kind of like this right here, but a little bit different. And you don't have to write the function, you just have to figure out which function does that operation. And this right here, this pile right here, this starts off as an empty string. It's kind of like collects letters, and you can tell it to collect letters on one side or the other side. Or how about this? What if we collect letters on both sides of our word? Let's see what that looks like. So now we have two H's, and then the E gets added on both sides, and the L will get added on both sides, and another L will get added onto both sides, and the O will get added onto both sides. So this is a pretty cool thing where you kind of have this pile that can collect letters onto it. We just concatenate letters onto it, and we can kind of make cool things happen that way. Now I want to show you a couple more things that we can do with strings. One thing that we can do with strings is multiply them. And that just makes that many copies of the word. So we have high 5 times. So that's multiplying strings right there. And another thing that we can do, if we have a sentence like this, we can call split on it. And split will, by default, it will break it up by spaces. So we have all the spaces right here. So what is this thing right here? Well, if you notice the square brackets, it's an array. It's an array of words. So we can just say our words equals and if we print it out, we have that. And then we could say words and the number 0, and it gives us the first word, or we can get the maybe the third word right there. So remember counting by 0, 0, 1, 2 right here. It's really the third word. So you can use this for your homework assignment. You're going to have to capitalize every other word. Only problem is, how do you make this thing come back together? Well, there is something called a join, so we can use a space and join that with our words and we combine all of those words in an array back together. So I've added another new function here where we get in a string and we split the string by spaces. Now we can loop through each word individually, and we'll print out that word in uppercase. So let's see what this function does. To do that, we have to call it down here. And let's see what that does. So, and maybe we might not want to do reverse words, so our output is a little bit cleaner. But notice we have hello class, how are you today, and it's all capitalized. One thing that we can do is instead of just printing it out, we can say word sub I equals the word, so it gets replaced. We grab the word in the ith spot, turn it to uppercase, and replace that with its original spot. And we can just, at the end, print out our words and make sure they're all uppercase. Let's see how that works. And sorry, this is words, not word. So now we have them all capitalized. And if we want to, we can join them back together into one sentence like this. And we get all the words back together. So now how do you capitalize every other word? That's what you're going to have to do for your homework. I will give you a hint on your homework, and it might have to do with range. Remember, if we do range 0 to 9, like this, with just 2, we get the numbers, well, 0 to 10, and we get the numbers 0 through 9. What happens if we do range from 0 to 10, but add 2 each time? Now we only get the even words. And what if we want the odd words instead? Well, start at 1 right there, and now we get the odd ones. So maybe if our for loop used this range instead, then we might be able to get in every other one. So that's all about strings. It was a lot crammed into one video, but you'll have a couple of days to watch it. And then there's 2 homework assignments, mirroring strings and advanced string manipulation. So I'm trying to give a lot of hints on how to do your homework, so make sure you go back and watch the video or look at the different parts of the video to see if you can find the hint for each problem. Thanks for watching.